talk about all this stuff, but then that's the only time you really ever talk about it, and you probably forget about it very quickly. But if you have a lovely little circle like this, I just kind of drew the XY plane around it. You don't necessarily have to do that. But if you drew this lovely little circle where this, where this is theta. Theta is our favorite Greek letter to use when we're talking about angles. Theta will become your friend in trigonometry class. This is a circle, so the length of this little arc here, both of those would be the radius of the circle. And then this outside arc, right, it's not a straight line, we call that the arc length. And if you wanted to find what the angle was, if you wanted to find out what is theta, you can take the arc length, you can take S, and divide it by the radius, and that would give you the value of that angle in radians. Really important that you're in radians, not degrees. And so if they gave you a problem in degrees, you have to first convert it to radians. This formula only works in radians. What we kind of use more often is we're trying to find the arc length. Like they give you an angle and they give you the radius, and you want to find the arc length. So if I wanted to solve this equation for S, what would I do, or what would the equation be? Theta divided by R to get S by itself? Right, because I'm going to multiply both sides by R to get S by itself. So we could say, I kind of said that already. Kind of got ahead of myself. S equals R times theta is what I was really trying to get you to down here. Sorry, this is just this equation written out in words. Theta is the angle in radians equals the arc length divided by the radius. It's feeling extra wordy, I guess, when I wrote these notes. So today, a big portion of your homework is pretty easy. It just says find the arc length, and they give you the radius, and they give you theta, and what you're finding is the length of this. And then we're going to apply this to some story problems, which means we can actually find the arc length of, wheels on a bicycle, or maybe how fast is a Ferris wheel going. That's pretty important stuff. Someone that has to control the Ferris wheel so people don't just get thrown off of it, someone has to do it. Maybe not you, but some engineer had to make the Ferris wheel. Probably not the guy working the Ferris wheel does that. He just pushes a button. But the guy that put the motor in the Ferris wheel, he probably had to know, how fast it should go. You think all this stuff just magically happens. It's all math. All right, let's practice. So this is a formula that you need to know for quiz, for a test. If I say find the arc length, you have to know that arc length, which we call S, equals R times theta. If you know that, then it's not that hard to do. So my first example here says theta is 5 pi fourths. I know that's in radians because, one, there's a pi in it. That kind of lets me know. And also there's no degree sign next to it. And the radius is 20 millimeters. That's a pretty small circle, 20 millimeters. And we're going to find what would the arc length be for an angle that's 5 pi fourths and the radius is 20 millimeters. So I would get S equals 5 pi fourths times 20. And I know you're all big calculator fans, but this one's not so bad. I could just simplify here, and that would be 5 times 5, I'm going to say is 25 pi. If we're talking about length here, what do you think the units I would put on this? Millimeters. And how much is 25 pi millimeters? I'd probably multiply that on my calculator. 25 times 3 is 75. 3.14. That's a decent size arc length there. That's it. Let's find the arc length. That's not cursive S's in math class so that you don't think they're biased. You don't have to. 21 pi feet. 12-foot radius, that's a pretty big circle. You okay with that? Arc length. Not very exciting. Alright, so now that we know what arc length is, or maybe I've reminded you of arc length, we can talk about how fast something that's circular is moving and how many, what's the velocity of something that's moving, given a specific radius and angle and all this stuff. So, some words here for you. Rotary motion is just motion in a circle. Angular velocity or angular speed, what's the difference between speed and velocity? Okay, maybe take a physics. Velocity includes direction, which means velocity can be negative. Speed is the absolute value of velocity, which means speed is always positive. Good job. A big part that I remember from trigonometry in high school is they always give you lots of letters, lots of Greek letters, and so you get to practice your Greek letters here. This kind of looks like a W there, right? But it's a little curvy W. Anyone know what letter that is? Not W. It's Greek. Omega. We should have like a Greek alphabet quiz. Just kidding. So there's lowercase and uppercase Greek letters, and what's going on the bottom of the chest? So they always use omega for angular velocity and speed. It's kind of just like a W. It's okay. I'm not going to test you about omega. This is our theta, which is our angle. Again, this has to be in radians. And per unit of time, T is just time in whatever unit they give you. If they give it to you in minutes, if they give it to you in hours, right, that would be so much over whatever time unit that happens to be. So, we can solve problems that say this. Find the angular velocity, and I kind of shortened that up as much as I could. Find the angular velocity in radians per second for a wheel making 2/3 of a revolution in 3 minutes. That wheel's going pretty slow. So again, this is just a formula, but it's really important that we know what the question's asking us, like what units we should give our answers in, and make sure you pay attention to what they give you in the problem. So since it says angular velocity, I know I'm going to use my little formula up here. I know I'm going to use omega equals theta over time. Something else that I'm going to look at is I want my answer to be in radians per second. They didn't give me radians or seconds in this problem. The easiest one maybe to deal with is the time. They gave me 3 minutes, but I want that in seconds. So can you tell me how many seconds are in 3 minutes, or how I can find that? Right, because we're just going to take 60 times 3, right? So I know that I'm going to put just 180 seconds on the bottom. Are you okay with that? What about the angle? All I know is the wheel made 2/3 of a revolution. How can I figure out how many radians are in 2/3 of a revolution? How many radians are in one whole revolution? 2 pi, right? There are 360 degrees in one revolution. And there are 2 pi radians in one revolution. So remember yesterday we kind of wrote out, like, how did we do, like, half a revolution? Yeah, we took half times 2 pi, and then we did, like, a quarter of a revolution. We took a fourth times 2 pi. So if I want to find 2/3 of a revolution, let me just do a little side work here. 2/3 of a revolution, just like we did yesterday and we multiplied by like 180 over pi and pi over 180, could I say I know there are 2 pi radians in one revolution? Right? That's kind of another little conversion thing. So how many radians are in 2/3 of a revolution? 4 pi thirds. That doesn't look very pretty. How do I simplify that? What do you do when you have a fraction and a fraction? Just punch it in your calculator, right? How do you do that? How do you do like 3/2 over 2/5? If you didn't have a calculator, what do you do? Multiply by the reciprocal. So especially, you could just take pi out of this and use your calculator, put pi back in it. But you really need to be comfortable with fractions. We're going to use them a lot. I'm going to write this as 4 pi thirds times the reciprocal of that, which would be 1 over 180 seconds. Does 4 go into 180? 45 times. 3 times 45. 135, I think. Yeah, I think so. Pi over 135. And again, the units are, what are the units of this over this? This is radians per second. So we have pi over 135th radians per second. And if you want to put that out as a decimal, you can. I think exact answers are better, so I keep pi in it as much as possible. That's what angular velocity is. Not that exciting, right? We can go one more step and do something called linear velocity, and that's what that means when we can find how fast Ferris wheel's going. What we're all leading up to today. All right, so here we go. You might need to make sure you have that down. This is my last little definition. My last little formula of the day. So we have angular velocity, which is just like the angular displacement over time. Like how much is that? And then we have linear velocity or speed. Is the linear distance traveled per unit of time. So normally when we measure distance, we measure it in a linear way. And so linear velocity is, although it's revolving on a circle, we can measure the linear distance traveled per unit of time. And so this kind of builds on something. It's like a little formula that we're going to build. That's just a V, it's not a fancy Greek letter. Just standing for linear velocity. T is still just time. And S is what we talked about before. What did we call S at the beginning of these notes? What? R times theta. S was that arc length, right? So this is arc length over per unit of time. And Leanna, I believe, said that we know that arc length is R times theta. And so we actually could change this formula to V equals R times theta over time, if you prefer. And then maybe we could go a little bit further if you want to. We just said that Angular velocity was omega equals theta over time. So technically speaking, could I kind of group this together and say this is the same as r times omega? Oh, how about that for some fancy substitution? I'm not going to lie that this is usually the formula I write down because I need my radius, I need my theta, and I need my time. But that's just kind of a little way to write it if you want. So this is okay to write as your formula, or I usually just write it as r times theta over time. Either one of those. Because it all means the same thing. All right, we're ready for the first one problem. I've been building up for it. What? You could. I'm not going here. I feel this Ferris wheel is going much too fast for me. But it says, calculate the linear velocity in feet per minute of a person on the rim of a Ferris wheel, 208 feet in diameter, that takes 20 seconds to rotate once. That's pretty fast. I might throw up. I threw up on a Ferris wheel once. What? I know. Well, I wrote this other thing first that spun all around, and I was really feeling ill, and I just wanted to go sit in the car, and my grandma said, "Ride the Ferris wheel. It will help settle your stomach." And so afterwards. And yeah. So here's what I know. This is what I found out about a Ferris wheel. As you're feeling really nauseous, when you come over the top of the Ferris wheel on the way down, there's a little moment that gets your stomach every time if you're about to throw up anyway. And so I was just trying the whole time. Oh, and I was 16, and I was with my boyfriend sitting in the Ferris wheel with me. And we were going around every time I was just like, please don't throw up, please don't throw up. And and then we're stopping, we're letting people off one at a time. And we were two more away from getting let off the Ferris wheel so I could go and throw up. And I just leaned forward and just threw up all over the ground. And they're like, who throws up on a Ferris wheel? And then I got off the Ferris wheel and I looked at my grandma and I was like, I'm going to the car. And then they had one of those big slides where you get on the whatever. And I felt sick again, so I just like the edge of it had a little ruffle around it or whatever, I just pulled the thing back and just threw up all underneath the slide. On my way to the car. That's terrible, right? Yeah. I didn't want to throw up right in the walkway of everyone, so I was trying to be discreet, and it was awful. No trash cans nearby. I don't know. I don't know. We probably ran away, but it was awful. It was embarrassing. And I'm like, who throws up a Ferris wheel? I think I would go on this one. What do we got? Theta over time times r, or theta r. It doesn't really matter here how we do this. What do you know? What is the radius? Right. They give us the diameter, and the radius is half the diameter, so the radius is going to be 104 feet. What about time? We know not time is 20 seconds, and we can go ahead and just plug in 20 seconds. They want us to change it to minutes eventually, so we're going to have to change seconds to minutes. So you tell me, do you want to just plug in 20 seconds now, change it minutes later, or can you tell me how many minutes is 20 seconds? 1/3, right? Because again, we can do a little, that's supposed to be 2. 20 seconds, and you could say there are 60 seconds in 1 minute. 20 over 60, 1/3 of a minute. traveling here? Like, what are they wanting us to find? We're wanting to find the velocity of a person on the Ferris wheel, 208 feet diameter, that takes 20 seconds to rotate once. Remember the last problem, it said, how long does it take to make 2/3 of a revolution? This one, we're going all the way around the Ferris wheel. Do you agree with that? So what would the angle be if I'm starting and going all the way around? 2 pi, because it has to be in radians, right? 360 degrees is all the way around, but we have to use this in radians, 2 pi. So what do we have here? 2 pi times 104 feet all over 1/3 of a minute. I'm not very much in the habit of putting my units in the problem, but you should put your units in the problem because it helps you know what units to put in your answer. And so my answer is supposed to be in feet per minute. So just by labeling this in my problem, I know that I have this probably set up right because I have feet per minute on here. And again, you can just use your calculator here. Kiss your marker goodbye. What? Did you see that? Why did that pop up? I don't know. I did a bunch of different things here. 2 times 104 gets us back to 208 pi, right? And dividing by 1/3 would be the same as multiplying by 3/1. Do you agree with that? No? Maybe? Yes? 624 pi? Feet per minute. Again, I feel that's that's too much distance to be traveling. Feet per minute. That's a lot. Okay? Ferris wheel. Maybe I'll give you a problem like that.
What else could you just go with?
Anything that's going circular, like moving in rotary motion, you could find the distance on. So what else is circular? Oh, yeah. Yeah. Or even like a bicycle, you could use to figure out how, like if the radius is this much and I'm riding this fast, how far am I traveling, or how many times is it going around and around, or wheels on a car. So you're right. We could do all the circular rides at carnivals. One more, and I'm done. We could also find the perimeter of pizza. That's exciting, right?
Okay, so if that piece of puzzle before, if we would have asked us to find the rotated twice, but for beta, would we have used four?
Beta. You said beta, but it's theta.
Beta?
Theta. 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 That's right. I was just talking. Find the perimeter of a 30-degree slice of a large 8-inch radius pizza. I don't feel 8-inch radius pizza. Oh, no, that's right. 16-inch diameter. I'm going to draw a little slice of pizza here.
So large pizza, which is large.
12-inch diameter or 12-inch radius? So I'm going to just draw this lovely little 30-degree pizza because, I'm sure the pizza people always make sure they cut their pizza slices in equal angles. Do you ever get that, like, really skinny slice of pizza and you're like, what?
I was like the one across from it.
So this is 8 inches and this is 8 inches, yes? What about this? What is this called again? The arc. So we could use our arc length formula. I'm going to call this S. Yeah, I kind of drew this whole pizza and I was like adding them all up. And ridiculous. Arc length equals what? Do you remember the formula? R times theta. So that's just going to be 8 times 30. It has to be in radians, so we have to make sure that we change that 30 degrees into radians. You can do it right here in the problem, or I'm just going to kind of do it to the side here. What do we multiply by to go from degrees to radians? Pi over 180, because I want those degrees to cancel out. Pi sixths. Do you agree with that? What's that going to be? 4 pi thirds? No? Yes? I could divide by 2 over 4 pi thirds. So my perimeter of my pizza is going to be 16 plus 4 pi thirds inches. That kind of doesn't make sense. Like, how much pizza is that? Because I'm adding up all the edges. Does that make sense? Sorry. I did this on my calculator. Like, I actually added, like, I did 4 pi thirds. 16 plus 4 pi thirds. And if I'm rounding to the nearest tenth, I got about 20.2 inches of pizza I'm eating there. I think it makes more sense if they asked us to find the whole the whole pizza. But what? I don't know. Yes, probably. What we're used to from our giant pizzas. 30 degrees is pretty small. Yeah. Probably they're usually about 45 degrees. We'll get a protractor out. We should order pizza and measure the angles. That would be a good project. At 9 in the morning. I think